We're going to talk about the voyage of Charles Darwin, sort of how a bit of his biography and how he came to his famous theory. Um, and I mean, you can read a biography of Charles Darwin. You can go to Wikipedia and read a biography of Charles Darwin and learn a little bit about him. But what I want to emphasize tonight is I want to emphasize how he was a naturalist, that he was somebody who was interested in the natural world. His curiosity about the natural world is what led to his famous theory. And so I want to kind of reflect on that, talk about kind of where he was as a person, what kinds of things he experienced, the road he took in order to get to the point where he penned his famous book, The Origin of Species, and a little bit about what the reaction was to that. Um, One of my references for this is actually a popular press type of novel on Charles Darwin. This is by Irving Stone. If it The Origin of Species is pretty dry. It's not great reading. He has an autobiography of his own. I have not attempted Charles Darwin's autobiography, but I have read this, and this is kind of what got me interested in Darwin as the person. It's a biographical novel, so it is a novel. It makes up dialogue and things like that. But Irving Stone researches his subjects thoroughly. So he's just not making it up. It's not a dramatization where he does his best to reflect actual events in Darwin's life, but give them their own life by providing, voices to the characters and so on. So I really enjoyed it. It opened my eyes to Darwin. He was just that bearded figure um, in the past. So I recommend this book to you. Easy read, written for just regular folk. Well, here's a giant wall of text, and this is talking a little bit about Darwin's evolution. That is Darwin's contribution to the theory of evolution. And it's nice to know this from the beginning. We'll start at the end, really. This is kind of where he ended up, but we want to see from his life how he kind of got to this point, how he came up with this idea, okay, of actually natural selection. Charles Darwin did not invent the idea of evolution, um, that one species might change into another over time, might evolve to become a separate species later on. That idea was already under debate when Darwin was throughout Darwin's life. The idea was brought up earlier in the late 1700s in several contexts. Not necessarily a developed theory as we understand evolution today, but some of those basic ideas that species might be able to change over time and maybe become something different from what they are now or from the past to now. Okay, so Darwin's contribution was the idea of natural selection. Okay, and so he provided a means by which these characteristics might change. So up until then, you didn't really know. We'll talk more about this and explore it a little bit more a little bit later on. But basically, that's what it comes down to, is his contribution was the idea of natural selection. So these points are the four tenets of Darwin's contribution to this whole larger theory of evolution. And it has to do with natural selection. So the first point is more individuals are produced each generation than can survive. Okay, you can see that all the time. I go down to the pond at Beechwood, I look in the water, I see thousands of little tiny bass that have hatched, and only a few of those are ever going to make it to adulthood. So that's an observation, not really a conjecture. It's plain old observation. Observation two, physical variation exists among individuals, okay, and the variation is heritable. That is, you can inherit that. So if you have a cat with white fur, there's a pretty good chance the offspring are going to have some white fur. Maybe not all of them. Okay. And you can have some cats with some fur and with some colors, orange fur, and some cats with black fur. But on the whole, if you've got orange or black in parenthood, it's probably going to show up somewhere in the kid. So you can inherit these physical characteristics. That's another observation. There's no real theory there. It's just what he saw And then he put these things together and he said, well, his theory is, and his contribution is, that individuals with heritable traits better suited to the environment will survive to reproduce. Okay, that was his big idea, that they will carry, these traits will be carried forward, will be inherited by offspring and carried forward. What makes the difference? It's the fact that those traits will contribute to their ability to survive. Okay. And if they survive, they can reproduce. Pretty basic idea that we think of quite a bit today in biology. But back then, it was a new idea. He was the first one to really figure this out. And then how do you get to new species? If this idea of natural selection is taking place, well, then when you start to get individual or populations that get separated from each other by geography, okay, then they will start to go their own ways, and their heritable characteristics will start to drift apart from one another if they don't come back to interact again. And so over time, that's where you're going to get that new species. You're going to get something with new or species or new characteristics will appear in the in the visible parts of them. I can't really say the genome, or because genetics was nobody knew anything about genetics in the 1800s. Okay, they didn't even realize what chromosomes were. Okay, they didn't even know that chromosomes had anything to do with reproduction. They were still figuring that out. Okay, Mendel, who did the genetic studies and the dominant and the recessive traits, he published in like 1860, and nobody knew it. He published a paper and everybody ignored it. It just never appeared on anybody's radar. Okay. So nobody knew anything about genetics. Nobody knew anything about chromosomes or even how traits could be inherited. The molecular biology or the cell biology of that. None of that stuff. He was just going on what he saw as he walked through the world and observed things. All right, so that's the foundation of where he's actually headed. Okay, let's see how he got there. So again, just a couple more points to give you pictures to look at instead of wall. This is basically the idea of evolution here, is that you have species with characteristics that will change over time. Okay, and how do they change over time? Well, those characteristics that create the better ability to survive will be the ones that are most likely to be carried on, because those individuals will survive to be able to reproduce. And so you get from primitive horses to the little tiny things that are hardly bigger than an antelope or a large dog, to the point today where we have these big, horse powerhouses. All right. And then another aspect of it is, again, trying to explain things like this is another thing that is going on in Darwin's mind, is how do I get from I have all these animals that are obviously related to each other, but they're not the same. They can't really breed with each other a lot reliably. There's a little bit of that can happen, but you end up with this weird combination that doesn't look like anything else. Okay. So this forms it, and then we get to the final extension of this idea of evolution, is that, well, if one species can change into a next, then maybe there is a common ancestor, okay, to them. Maybe there's a basic horse from which horses have expanded. Okay. And then you can apply that all the way back to the idea that you can get all the way back to maybe a single ancestor of some kind, a single-celled, single ancestor, if you go all the way back. Okay. So, well, the point here, though, is that flows from the theory of natural selection, this idea that we have a common ancestor. Natural selection gives you a means by which you can explain why or how this happened. Okay. All right. But it was not a premise of the theory, in that Charles Darwin didn't sit down and go, you know what? I think everything came from a common ancestor. Let me prove it. He didn't start that way. He started from, we've got all this stuff at the top of the tree. Maybe they all are related. Maybe they came back from something. But anyway, we'll get into more of that later on. For the purposes of our discussion tonight, let me just say that we are just taking evolution as the theory as it is understood. I'm not really interested in debating the merits of the theory, but just as it is understood today in modern biology. So how did Darwin get to this point? Well, here's where Darwin came from. He was born in 1809. He was the fifth of six children, which is kind of an important aspect. Darwin kind of had to find his own way. He wasn't going to inherit leadership of the family. He was going to have to kind of find his own way. And we note that his family was a devout, or at least a prominent Anglican family. So they were active in the local church, and so on. And so he came from that background. He came from a background that was a churchgoers. His family, if you know what this china is, this is Wedgwood china. Charles Darwin married his cousin, but he was married into the Wedgwood family. So the Darwins and the Wedgwoods, his mother was a Wedgwood, his father was a Darwin, and well, they were a family of means. They had money. They were independently wealthy. Okay, which will help if you want to live the lifestyle that Charles Darwin is going to live. There was some unorthodoxy in the family. Okay, his grandpas were both prominent abolitionists. Okay, Erasmus Darwin considered himself a free thinker, which was kind of a, not really anti-religion, but just sort of, or in that way, sort of a free thinking, sort of detached from the received view of which in many times was governed by the church, okay, and so on. So he was a free thinker, which is its own movement of the late 1700s. Josiah Wedgwood, his grandfather, was a prominent abolitionist, and he wrote some things that basically said that all humans are created equal, more or less, that they are equal. Okay, so which would be counter to some of the racial and racist views that were common in that day. So he was headed that direction. I wouldn't say necessarily, that's a tricky topic of its own. And it was a journey to get to the point where we have today, the recognition of civil rights and equality of all races. It was a journey, and he was taking a big step on that journey. Okay, let's talk about another journey. This is Darwin's academic journey. In 1825, he entered university for medicine along with his brother, who also entered for medicine, but he didn't really like the sight of blood, so it wasn't really working out for him. So he wasn't doing well there. So his father was kind of watching him through this whole process. And his father said, well, if you're not going to be happy there, let's get you into Cambridge instead. And he studied basically a pre-theology degree. Okay. It's called an ordinary degree. In 1831, he received his Bachelor of Arts degree. He was 10th of 178, so he was no slouch. And his career goal, Parson naturalist. Yes, so that was what he was kind of thinking at the time. Now, what would he do to do this Parson naturalist? Well, we'll get to that in a moment. Now, what did he do at this time while he was in school? Well, as we said, he did pretty well once he applied himself, but he was not really keen on school. He kind of washed out of med school, and then he went down here to kind of get a generic degree, more or less, from Cambridge, have a degree of some sort. All right, but what did he do at this time? Well, he was a huge Beatles fan. Darwin was a huge Beatles fan, and not these Beatles. They weren't around yet, but these Beatles. He would go around and collecting beetles from the countryside. He would go on long forays into the woods with friends and alone to go looking for cool insects and things to collect. In particular, beetles was a fascination of his. So when he graduated in 1831, he had the makings of a gentleman naturalist. All right. He had money because his family had money. His dad paid for his college. He had time because he really didn't need to work um, in order to survive. So he had time. He had a serious interest in science. Okay, as we could see, he did his beetle collecting. Okay, and not just, I mean, we're not just talking, oh, a couple of cool beetles. He would keep extensive notes on these and catalog them. And he actually, during his time in college, he actually contributed to some academic writings on beetles and other insects. So he may not have been the greatest student of the thing he was supposed to be studying, but as far as natural history goes, he was top notch, and he was definitely involved in science, even if it wasn't his degree at the moment. Okay. Um, so another thing about these gentlemen naturalists is that that was kind of a way that a lot of these famous people that we think of in these 17 and 1800s, people like Francis Bacon or Boyle, okay, from Boyle's Law, and just to pick a two that come to mind. A lot of these guys were of means of their own, okay, and they would spend time tinkering about sciences in their spare time. You really weren't a professional scientist back then. Nobody was paying you to be that. You could be paid to be a theologian. You could be paid to be a parson or a you know a preacher. Okay, um, you could be paid to be a laborer. All right. If you want to be an academic, you were usually involved with a university, but often universities were sponsored by churches, so there was a theological part to it. And you kind of did science on the side. So, or you might have been from a family of means, and then whatever their industry was doing that for you, because that's how you had to do it. Okay, to be a scientist, getting a wage wasn't really a thing. A lot of these scientists studied science in their part time and in their spare time as gentry, if you will. Okay, very common model in the 18 to 1700s. All right, now, but you still need your day job. Still important to have a meaning in this world. All right, and the family wanted you to have a day job. You're not just going to sit around the family home and as a ne'er-do-well and not do anything, be a playboy or whatever. That wasn't going to happen. All right, you need something respectable. In very many cases, something respectable was to go work as a parson, to take on a parish, and take care of the parishioners in your parish as part of your church. Okay. So that was kind of where he was headed when he got out, thinking, well, and again, he was an Anglican at the time. And so he was, I'll just get myself a little parish somewhere somewhere in the suburbs of London somewhere, and I'll, make sure the church gets taken care of and do a little speaking on Sundays or whatever else is that they do. And in the meantime, you can go do a sciencey thing. All right. Well, again, that was a step. He had to get that way. And then another opportunity presented itself to Darwin. All right. And we have a little note here that says, thanks, Dad, because Dad bankrolled this. And Dad kind of said, you know what? He needed something for his son, Darwin, to do. All right. Because he wasn't the eldest, so he wasn't going to be running the family business, most likely, but he still needed something respectable. And his dad kind of was following along and seeing what was going on and see where his interests lie. And he heard about this opportunity and pointed Darwin toward it to be basically a geologist or a scientist on the HMS Beagle, which was going to do a survey of South America, particularly following along the coast. So it would land on the coast. They would go in and survey. They would be mapping the board. They would be mapping the coast, and then the quote scientist of the Voyage would hop off, and he would go explore while they did their mapping and catch up to them and get back on a little bit later on. Okay, so this opportunity came off. They're going to be it's supposed to be like a 2-year voyage, but it stretched out to 5. With all the travel that's involved, and Darwin needed to pay his own way, and Dad footed the bill to put him on this boat. So why was he there? Well, the captain of the boat was Captain Fitzroy, and Fitzroy wanted a companion. So it wasn't just, oh, that it wasn't that a geologist or a scientist was going to be assigned to the boat as a matter of course. The captain decided he wanted one. And of course, Darwin had to pay his own way. So it wasn't even part of the funding of the voyage. Okay. So Darwin paid his own way. Fitzroy wanted an equal to speak to because it was just him and, a boat full of sailors. And he kind of was hoping for a scientist because he had done this voyage or something like it before, and he was had an interest in these things as well. He saw the potential here, and he wanted to have a geologist along to help him understand what was going on. So he wanted a companion as well as an authority along to kind of help draw some interest out of what was being taken care of what was being seen. So the Beagle set sail. What was the prevailing thought as Darwin got on the boat? Where were we at with regard to where we're headed, with the theory of natural selection? Where are we when he gets on the boat? All right. Now, another point to make here is that often Darwin is associated with evolution. He's associated with everything that has to do with evolution, that concept of evolution. But really, some of the major underpinnings of it were already being put forth in other locations. So these ideas were percolating all through the 1700s into the 1800s. All right. So when Darwin got on the boat, uniformitarianism was hot off the press. This is Hutton, and he put out a book, Uniformitarianism, in 1830. And the concept here is that present is key to the past. That means that the rate at which things weather is probably the rate at which it's been weathering. And so if you can look and see how quickly things erode now, for example, extrapolate backwards, you can learn some things about how things were weathering in the past. And pretty much the conditions that are obtaining today are pretty much the same conditions that obtained in the past. And so with that knowledge, you can work backwards through a fossil record, through a sedimentary record in a canyon, and you can say that the ones on top are the newest, the ones on the bottom are the oldest, and every step in between represents a stage. And how those things are deposited, if we can look at an example today of how something similar is deposited, and we can say, well, those conditions probably applied back then and how it was deposited back then. This idea is probably not a surprise to anyone, because it is pretty much how we deal with everything today. From astronomy is the same way. If it's moving this slowly now, it's been moving that slowly all through history. Just how fast light moves through a vacuum. It's what it is now is the same as what it was before, and so you can work your way backwards with confidence. That was the idea of uniformitarianism. Okay. Evolution itself, the idea that one species, that we might have some sort of common ancestor, or that species might branch from one another, that idea was already being bandied about. In fact, Darwin's own grandfather, Erasmus, made some statements that kind of went along with this. He talked about first cause. Okay, so a moment in time in which things spread out from there. All right, and all warm-blooded animals have arisen from one living filament. Okay, wow, that's a very philosophical way of saying it, but that's basically the idea of evolution. That you can follow, that some species can follow one another and branch out. Right. So there it is. This idea is already banging about in the back. Sorry about the font error there. So, but the big question at this point was that nobody was really quite sure about, or perhaps a little afraid to go there, was the idea of transmutation of species. As we said, people were kind of saying, gee, isn't that sort of interesting? But they weren't saying it out loud. This idea of transmutation of species, that one species can become another, that species are not fixed, that 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 the you know pick any animal you want, that the robin, the robin is the same today as exactly as it was in the past, and it has never changed. It's always been a robin. It's never been anything else. It always will be a robin. It'll never change into anything else. Okay, that would be the idea of transmutation of species. If one species can become another. Now, my illustration here of a fish with legs is a silly way of saying that, but it's kind of that idea that one thing could become another. Could it happen? And it was up for debate. Okay, because nobody, you could say, well, maybe it kind of looks that way. And here's some evidence, all right, of it. Here's some things that I think people were seeing, and we think about this. Well, first of all, they were looking back and they were looking at ancient art for maybe, Egyptian times, 4,000 years ago. And the animals they carved were almost identical to the ones today. No change there in 4,000 years. Okay, so they hadn't changed. But then they were digging up fossils. And the fossils were showing similarities to animals today, but they weren't necessarily always the same. Okay, so that's a little piece of information going on here. And then we have this idea of husbandry of dogs, where you can get wildly different looks of dogs from selective breeding. Okay, all right. So you've got some stability here, like things from 4,000 years ago hadn't changed much. But you got a potential for change, because you can change the dogs in a few generations to be from one crazy thing to the next. Okay, so it's possible for things to change. We do it with dogs. We didn't make a new species, but at some point you get to the point where the Chihuahua and the Great Dane have a hard time breeding, and so maybe they would become separate species eventually. Okay, you can see where it could go that way, right? And then the idea of fossils, even more so, was that at this time in the late 1700s and early 1800s, they were digging up fossils all over the place, because now they were mining increasingly, digging up coal increasingly for the Industrial Revolution, needed resources. So they were digging all sorts of things up, and they were stumbling across fossil after fossil as their digs got bigger and bigger, and they needed more and more raw materials. Okay, and they were finding some fossils that were clearly had relationship to animals today, but they were not the same. And there were some fossils that looked nothing like what we have today, except maybe they had teeth or whatever, but they were just dramatically different. Where did they go? What happened to all those animals, these fossils of animals? Where'd they go? Okay, why are they, anyway? So these are all the puzzle pieces that are banging about in science as Darwin gets on the boat. All right. Now, as I said, the idea of evolution was not necessarily something that Darwin came up with. It was already being banged around. And the idea of transmutation of species, how we might get from one species to a next, or get change in species, how could it happen? What would be the mechanism by which you could get this to work? Okay, remember, they didn't understand genetics yet. It wasn't even invented. Nobody knew anything about genetics at the time. Okay, this was kind of one of the first attempts at explaining evolution. And Darwin would have been familiar with this idea. This is the classic giraffe example, where the giraffe is reaching for those tall leaves. And so he stretches his neck to reach it for those tall leaves. And if he stretches it enough, when he has babies or fathers children, that baby is going to have a little bit stretched neck too. Okay, so the activity of doing something is going to be and changing, stretching, or is going to appear in your offspring. All right. Now today we're like, you've got to be kidding. That makes no sense whatsoever. But back then, they, without genetics, they're like, well, maybe this is how it works. All right. Now, when Darwin got on the boat, kind of where he was at with all this, with an answer to this, was he was an Anglican when he got on the boat. He, in fact, was known by the other sailors as being sort of the moral authority on the boat, and he would use the Bible to, convince them to live the right way with a group of sailors. But as far as the science goes, he got on the boat and he was going to look for, he was expecting to find this idea of centers of creation, sort of another way of trying to reconcile all these different animals. And the idea of centers of creation would be that instead of just one spot where animals were created and they spread out, but that there may have been several spots around the world. For example, the animals in Australia are so different from the animals in other parts of the world that maybe that was a center of creation. Maybe that was a spot where you had a little spot of creation and boom, animals spread out from there. And maybe there was a drop in South America and those animals spread out. And so they have they have unique characteristics because they came from the same center of creation, and there would have been multiple centers of creation across the planet. So he actually got in the boat thinking maybe he would find a center of creation in South America. Well, here's where the Beagle went. 1831 to 1836 was the voyage. I think it was supposed to be a 2 or 3 year voyage, and it stretched out. The last year of the voyage was just the trip back. All right, so really about 3 years of the voyage was the hardcore survey. They left England and went to South America, and they creeped along the coast, and that's where he spent most of his time, most of those couple of years, creeping along the coast, got to the Galapagos, and that was pretty much his last hurrah, and they went zipping across to Australia and New Zealand and on their way back. He did a few observations on the way back, but the bulk of his observations were in South America. That was the target of their voyage. That was where they're supposed to be spending most of their time. This is Darwin at sea. He was plagued by seasickness that he never got over. So anytime they were underway, he was in his hammock, writhing in discomfort. He never got over seasickness. So he was more than happy to hop off the boat. What the ship would pull in to port, he would hop off, and then the ship would go do its surveying thing of the coast, and he would make arrangements to hop back on the boat. And so he spent most of his time off the boat. I believe it was about 3 years of time he was off the boat. It's like a 4-year voyage, more or less. And for 3/4 of the time, he wasn't on that boat, and he hated being on that boat because he was so seasick. And what did he do? He took notes, and he collected specimens, hundreds and hundreds of specimens, loaded them up, and shipped them back in crates. Okay. So he brought, he had some on the boat with him, but he would actually mail them back home. And back in England, the professors there would unbox the crates and begin the cataloging process. So he was collecting specimen after specimen and sending it back. And he was taking extensive notes. Here's some key observations that he made on his way. One observation was this idea of gradual change over time, or uniformitarianism in geology. Okay, uniformitarianism is basically a geological concept as we're using it here. I mean, the idea, you can extend it to other things, but uniformitarianism is a geologic concept. And so he was saying, you know what? I do see that. And here's what I see. I can see fossils on the top of well above the water. How did they get there? Well, one day he observed an earthquake, and the earthquake was such that the land shifted and it stranded some sea creatures above the water, above the high tide line, where they would never get water again. They were just going to die right there. So he saw that the land could change, and you could have something, find its way out of the water that used to be in the water. All right. And then he could see, like, you could step your way up the side of the mountain. You could see if this kind of thing happened periodically. Okay. That, you got fossils, the same fossils show up at different levels of the mountain. Okay. Because things were changing. All right. And it could be a quick change, like as an earthquake, as an example of one of those quick changes. All right. But, you could see it in slow motion too. That earthquake, just a little jump. Okay. One jump, and maybe, how often does an earthquake happen? Once every, hundreds of years, like that. But there are fossils on top of that mountain, if you will, on top of that ridge, okay, that are connected to the ones down here. So, there must be some gradual, progressive thing is happening. Over time, things are happening. It wasn't all one-shot deal, but you're getting earthquakes, and you're getting earthquakes, you're getting erosion, you're getting uplifting over time. Okay. And so you're getting that. And he said, yep, I see uniformitarianism. It explains what I'm seeing. Coral atolls, the same way. He explained what coral atolls were, and his explanation of coral atolls was unique to him, but it turns out he was right. It was a bit of a mystery about how this worked, and he figured this out. Now, it's a little hard to read this diagram. Isn't the way I do the diagram, but what you see here is the bottom dark section with the red line is the original sea level with a seamount. This would be a volcano that popped up. Okay. The black on the sides is coral. So the coral grows on the side of the seamount. Meanwhile, the seamount erodes over time, is being battered by the waves, and it is eroding. Okay. And so, but, or maybe the sea level is rising, but either way, the corals are keeping up with, as the mountain is eroding, but the corals are continuing to grow on the leading edge, and they're keeping up with sea level. All right. So they get to the point where you get to the yellow line. The yellow arrow shows you where sea level is now, and that dot, that curvy dot, that is where the coral is now. So now you've got this lagoon in the middle, and you've got the coral coming up the sides. What happened to the mountain? Well, it's down there, but it's eroded away well below the coral, and it's left just the coral sticking above the ocean surface. All right. So how is that going to happen? That's going to be a gradual thing, a uniformitarianism kind of thing. The mountain is going, because it can't happen in a hurry, or the coral wouldn't be able to grow fast enough to get back to the sea level if the mountain sunk suddenly. All right. So it's a gradual thing, slow enough that the coral can keep up with at the surface of the water while the mountain sinks down very, very slowly. Okay. So that's a uniformitarianism idea. Steady, slow change over time. Here's some key observations in biology he made on his voyage. So he was looking for, what he noticed was, getting to, again, we got in the boat, he wasn't necessarily thinking this, but as time went on, he's trying to make sense of what he's seeing. And he was seeing evidence for species being able to change. That's the idea of transmutation. And again, that was up for debate. Could a species become another species, okay, to the point where they would no longer interact anymore, right, and actually start to look different and go different ways? And he was seeing evidence for that. So this is what he saw. He observed this. He observed armadillos, and he observed the fossil remnants of glyptodons, which are basically an oversized armadillo, or looked that way. And he's like, well, there's no more of these glyptodons, but we still have armadillos. Maybe there's a relationship there. Okay. The glyptodon disappeared. Why did it disappear? But the armadillo is still here. What's going on there? Okay. Did one species change into another? Maybe. At the very least, one species completely disappeared. Why did it disappear? Where did it go? Okay. He also noticed this about rheas. He noticed that there was a north rhea and a south rhea. And it confused him as to, and they were different in subtle ways, but they were different. And he wondered, why have two species that are so similar? What's the point of that? They're not the same. They're distinct enough that you can tell them apart, but they look almost the same. Why so close to each other? Why not just be the same thing? Okay, but yet they're different, and they have different populations, and they're in different parts of the country, but they're so much the same. Again, that was another thing he was trying to figure out. So again, looking ahead, we could say, well, maybe he was seeing evidence that these populations were beginning to separate from each other. Maybe there was some sort of geographic difference between them, and they were distinct enough that they're beginning to kind of drift on their own. We would understand it as genetics, but he was just looking at the face of it. It just looked like they were becoming separate from each other as time went on. And then we get to one of his most famous observations, which would be the finches. Except the finches came along later. He didn't know they were finches. He thought these finches down here in the lower right-hand side, he thought they were all different birds entirely. He didn't realize that they were all related to each other, closely related to each other, but they just had different beaks. Okay, so they're much more closely related to each other than what he thought they were. He thought they were truly just different birds. But he did notice the mockingbirds. The mockingbirds are here on the left. The mockingbirds, they're almost identical in their overall, mockingbird shape, but they have distinctly different beaks. And he's like, what's going on there? What's the point of that? How could we have three species so similar to each other, but yet different in distinct ways and consistent ways? Like it's not just, mother had a long beak and offspring had a short beak. They were their own populations on different parts of the Galapagos Islands, separate, apart from each other. Clearly, they were related to each other, but they were diverging from each other in these ways. What was going on there? And so, and I say, I'm asking the question. We kind of know the answer that he was going to come up with, but he didn't have the answer yet. He was just gathering this stuff and going, what is going on? Okay, he didn't know at the time, but he was clearly seeing something going on. So he comes back in 1835. He brings back a 770-page diary, another 1,750 pages of notes, 12 catalogs of 5,436 skins, bones, and carcasses. Okay. All right. So he sent back gobs of samples, and he had tons of notes. So when he got back, well, nobody was going to do it for him. He had to figure all this stuff out. Okay. Now, they were cataloging things. Cataloging was a big thing back then because everything was new, and the idea of cataloging things and coming up with genuses and species, they were naming everything back then. Okay. That was a new idea. With Linnaeus and all that kind of thing. So there was a lot of cataloging going on back then, and which kind of goes with how Darwin ended up getting his thinking going. When he got back, well, now he had to, start cataloging all this stuff. And if you're going to catalog it, you got to figure out what's related to what. Okay. And then then that brings up the idea of, well, how are these things related to each other? What format do I use to try to fit these puzzle pieces together? How do I make my chart? What criteria do I use to put these animals together? But he was a busy man. He had lots of things going on. One of the things he did when he got back was, as was popular at the time, when he took a big voyage like this, you'd write a book about it. And Fitzroy wrote a book about his surveying voyages. And Darwin contributed a substantial section to that on his natural history observances. It turns out that his section on natural history observances was more popular than Fitzroy's account of the surveying voyage side of it. In fact, Darwin's was reprinted several times and revised, and sort of eclipsed Fitzroy's surveying voyages. Sort of became more popular than the original, if you will. Okay. So where was he at scientifically? When he got back, he wrote this book, and actually he was kind of a minor celebrity after that. So he kind of got somewhat famous with his Beagle voyages. All right. But he was convinced that geology can change significantly and gradually. Okay, so you can have big change, but the big change could take place over a long period of time. He was also convinced that species can change significantly, which would be transmutation from one species to the next, but that they can change gradually, because he was seeing minor differences between the mockingbirds, or minor differences between the finches, when he learned that they were actually finches and all the same, closely related to each other, or the rheas, or even the Glyptodon and the armadillo. He was seeing that there's a pathway. There's a pathway from one species to the next. He was beginning to see this. The geology part was already explained by others, all right? But transmutation still needed a mechanism. Yes, you could posit that one species can change into another, but you still have to demonstrate how it could happen. It's not enough to say, yeah, this looks like that. You have to be able to prove that that's the way it works. Okay. So it needed solid evidence of change. All right. He needed to be rock solid that he could demonstrate that species were changing from one to another. And he needed an explanation of how and why this would take place. Okay. Without those two pieces, he knew that he was not going to get anything published, and he was going to be laughed at if he didn't get everything all together. All right. And he was very, very concerned about that. He wanted to get this just right. Okay, before he published. And he knew because, the idea of transubstantiation, or excuse me, that would not be it, of transmutation, the idea of transmutation did rankle some feathers. All right. The idea that species were not fixed, that species might change. There were some religious implications of that. Okay. The church was a little bit like, and there was beginning to be a bit of a pushback against this idea because it was becoming counter to some understood theology of the time. So here's the case of selection in action. Again, this is stuff that informed Darwin. Husbandry saw that you could get capacity for useful change. You could get a species, you could develop a species of dog, excuse me, a variety of dog that could do special things. You could make a dachshund that could go into burrows and get things out. Okay. You can make a big old Newfoundland hound that can, or husky that can haul your sled around. Okay. So you could get useful changes in these animals if you kind of selected for it. Okay. But people can do that. What would do it in nature? What's the mechanism for nature to select for these good things, for these useful characteristics? All right. Well, again, the idea of natural selection actually wasn't even, the idea was brought to Darwin's attention in 1838 with an essay by Thomas Malthus, a very famous essay, The Principle of Population. He was talking about human populations, and he came up with a concept that if human populations continue to grow unchecked, they could outstrip their resources, which could lead to famine and a reduction in population. Okay. He was talking only about humans, but you can see where this idea might apply to animals in the natural world. Okay. This idea that maybe you could outgrow your resources and there's going to be reaction to that. Okay. All right. Not everything is going to survive. Remember back one of the tenets of evolution, of Darwin's version of natural selection, was that there's more offspring birthed than can survive. Okay. Well, that's kind of the idea here that Thomas Malthus came up with in 1838. So Darwin was aware of this. But he still wanted, so there it is, right? Natural selection, the pressure of survival might be what dictates whether a characteristic is passed along. He was like 95% there already in like 1838, but he was still 20 years away from publishing Origin. He didn't publish Origin until 1859. 20 years, he had this percolating in his head. What did he do? Well, he got married in 1839 to his cousin, Emma Wedgwood, kind of keep it in the family. He had 10 children, 7 survived to adulthood, and by accounts, he was a very devoted father. In 1842, he and his wife moved to Down House. This was be where he would spend pretty much the rest of his life, where he did most of his studies and work and writing. This is his study in his house. It has since been restored. You can go visit this. Okay, I've never been, but you can go visit Darwin's house, and it has been restored to kind of how it would look back in his day. It was sold out of the Darwin family after Darwin died, and so a lot of the original stuff is not there, but they have kind of recreated it, and maybe they've assembled some vintage pieces. I'm not sure, but at any rate, it is a place you can go visit and go check it out if you're in London. It is south of London in the suburbs of London now. Another favorite part of his property there at Down House was the sand walk. He made this. This is like his own little walking and thinking trail. And he made this himself, and he would walk it, and he would think about his work on this sand walk. It was a very important thing to him personally. Another curious thing about Darwin was that he suffered from a rather mystery illness. Okay. And this mystery illness had like every symptom you can imagine. You name it, it's in there: nausea, diarrhea, malaise, stomach ache, headache, fatigue, whatever. I mean, the list of symptoms is as long as your arm. And he would suffer this periodically, and it would debilitate him for a while, and then he would come back out of it. It was sometimes brought on by work, like he was working feverishly on some aspect of his work, and it would kick off these symptoms. And he suffered this all of his life, and it's still a mystery today exactly what was going on there. Was it psychosomatic, whatever? And this is one of the places that he would go for hydrotherapy to help do something to alleviate these symptoms. And he spent a good bit of time at this particular facility seeking relief. So some of the steps as we go along here, our first full sketch of evolution by natural selection, when he actually kind of like spelled it out, would have been 1842. In 1844, he sort of expand this sketch into an essay. And this is interesting. He gave the essay to his wife to publish if he should die. So he wanted this thing to be right, but he also knew that could be controversial. So he didn't want to necessarily step into it right away. All right. He was holding off. He figured this out early. All right. It took him 20 years to publish. All right. But he figured this out fairly early. And in correspondence, he said, species or not, and he put in parentheses, it is like confessing a murder, immutable. Okay. So immutable means unchangeable. So he said, by saying this out loud, he felt like he was going to make some people mad. Okay. So because he knew that this idea of being changed from one thing into the other was going to upset some people. All right. Now in 1844, this was published, which on the face of it sounds a lot like somebody proposed the theory of evolution and trumped for Darwin. This is called The Vestiges of Creation. It had caused a bit of a kerfuffle when it was published, but it didn't give any kind of mechanism. It did posit, and there's a drawing from it, an illustration, that there's a relationship between species. And it wasn't so much that it was trying to demonstrate that one thing could become another, but that there was a common root to these things. Like maybe they were created, but there was maybe a common blueprint, if you will, that kind of informs things. Like if you look at an embryo under development, at some point it gets even a human. At some point it gets things that look like gill slits, which is a very fish-looking thing. Okay, and eventually it becomes okay. Or if you look at an early embryo, it looks rather primitive, and it looks like could be one of the other animals. So there's like a common blueprint there, a common starting point, and then these things grow and develop. Not change from one species into the next, but rather as they develop as individuals, you can kind of see, echoes of other animals in the past. Like there's a common blueprint. All right, so not a natural selection, evolution kind of thing, but a common blueprint. And it caused a bit of a kerfuffle. And you can see that, yeah, it's kind of going that direction, but again, it's not saying the hard part out loud yet. So again, we got 20 years to kill. What's Darwin doing? Well, he's pussyfooting around his theory and kind of holding on, keeping his cards close to his vest. And then barnacles. From 1846 to 1854, he threw his energy into barnacles. All right. Barnacles. And because barnacles were a very confusing animal. All right. If you know anything about barnacles, they sort of start one way, and then they, as they develop, they sort of curl in on themselves and form a U shape in there. And then they get a hard crust that looks like it belongs in the mollusk family, but they're not a mollusk at all. They're a brachiopod. They're a crustacean. Okay. Um, And he spent a lot of time with the barnacles because he collected a lot of barnacles. England had a lot of barnacles around him to collect. And he was like, he's kind of obsessive about these sorts of things. And he wanted to catalog these things. He thought maybe by cataloging these things, maybe he could find some evidence for some of his ideas that were percolating in his head. All right. Well, he never really got there because barnacles are a rather difficult thing to sort out. And even today, very hard to figure out who's related to who. There's a lot of similarities, and they're just a very confusing animal. And so it didn't show up in my slide here, but with this quote in the bottom, you can barely read it, but it says, this is a quote from Darwin. He said, "I hate barnacles as no man before me." So he started these barnacles for 8 years, and he ended up hating the darn things because he just couldn't. They were just didn't work out. But he spent a lot of years on barnacles. All right. In 1851, a milestone for his family was his daughter died at age 10. Yeah, this says age 1, but it's age 10. And that was a traumatic thing for the family. They did have actually two of their other children died as infants. And, of course, that time in human history, child death was extremely common, particularly in infants. So those didn't seem to have as much an effect on him. But Anne was 10, and she was, daddy's favorite, and it devastated the family. In fact, he didn't even attend her funeral. At this point, it sort of was kind of the final straw for his estrangement from the church. He didn't really step foot in the church after that. He had been sort of wandering away from the church ever since he got back from the Beagle. Exactly what's going on in his mind, I don't think he was ever really clear about. But evidence is he just sort of, you kids and the wife go off to church. I'm going to stay home, and that's kind of where it stayed. Okay. And again, this was a watershed moment for their family that left a scar on the family for for his life, the loss of his daughter. It was devastating to him. Well, 1856. Remember, he published in 1859 is The Origin of Species. He still hasn't published yet. He's dilly-dallying with barnacles. He's writing essays and hiding them. And then Wallace shows up on the scene. This is Alfred Russel Wallace. He went to Papua New Guinea, the South China Sea, the islands there, Micronesia, okay, that area. And he was basically doing the same thing that Darwin was doing. He was cataloging things and trying to figure things out. And he started to stumble across the same idea that Darwin was already thinking about almost 20 years earlier. Okay. In fact, 20 years earlier. And so he was being to write back home and to scientists back in England, and the scientists kind of knew Darwin, and they've been talking with him because he was an accomplished scientist. He was talking with them, and I think he was discussing some of their ideas, and he wasn't keeping everything close to his vest, but he was sharing it with some of his colleagues. And they were like, Darwin, this guy Wallace, he's kind of talking about the same way you've been talking. You may want to keep an eye on him. Okay. And then in 1858, Wallace sent Darwin an essay to review that pretty much laid out the theory of natural selection. And Darwin went, oops, time to get on the stick. So he quickly wrote the book, banged it out. And then he was gracious, though. He invited Wallace. He arranged to have Wallace and his basic essays read at the same time. This is not the book Origin of Species just yet, but he wrote a big essay laying out these things, and he had Wallace and Darwin had their essays read for the Linnaean Society in London at the same time. It was a public reading, but nobody paid any attention to it. It just kind of went, something those scientists were doing over there, and nobody really paid much attention to it. Okay. So, but he was gracious, and he let Wallace have co-credit in that idea. But meanwhile, he got to work on his big magnum opus, which would be Origin of Species. And he cranked out the Origin of Species, and it was published in 1859. Now, as I said, the essay reading along with Wallace's didn't really shake anything up, but this did. This thing was actually sold out before the publishing was finished. Before the books actually came out, they would sell subscriptions to books back at that time. You could buy the book before it came out and you would get it as soon as it came out. And they sold all their subscriptions. They had to make extra printings of it. And it did create a kerfuffle. All right. So this is one of the only illustrations in the book. All right. It's a lot of words, not many pictures. I need more pictures than what's in the Origin of Species. But you can see where he's kind of going with this idea that you can have a common ancestor, if you will, and then you can get these branches. All right. So that's the tree of life idea. All right. But what was creating the tree of life? What was doing it? It was natural selection. And that was what we laid out at the beginning. The idea that there's more of an offspring that can possibly survive. Okay. We know that characteristics can be inherited. All right. Because you can see in one animal and see it in the offspring. All right. And his proposal was that animals that have more favorable characteristics will be more likely to survive, and they will pass on their characteristics to their offspring. And so those good characteristics will become amplified over time because they're successful. They work well. So they can continue to survive better. And so in the end, you're going to end up with something that looks different than what you started with, okay, or have branches. And the final idea was that if things are geographically isolated, that's when you're going to get these different species, okay? At least in the near term. In the longer term, it could change in where you're at as conditions change. But they're responding to the environment, and you could have or if a river shows up in the middle between two populations, the one on the left bank, and they can't cross it. The one on the left bank is going to diverge from the one on the right bank, and over time, they're going to look like two different species because they're going to be collecting different characteristics that work better for their side of whatever this divider is. So any geographic separation is going to help this process along. Okay. Well, as I said, boom, there was the reason why. That's how you get the change. It's natural selection. They're selecting by the basis of their survivability, okay, and inheriting those characteristics. Remember, there's no genetics here. There's no chromosomes here. There's no DNA here. Nobody knew anything about that. He's just telling you what he observed. Well, this set off lots of exciting times. Thomas Huxley. Darwin did not like the spotlight. Now, he got kind of famous here at this point because this actually hit the scientific community and it got some buzz going. And their debates were being staged. Darwin never took place in these debates. He hated that thing. He was just not that kind of person. But Thomas Huxley said, I'll be your champion. And Thomas Huxley did a lot of his debating on his behalf. And some very famous debates, as a matter of fact, especially in this early 1860, just after it's published. We're having these debates and people are having words over it. All right. And it was a paradigm shift. It really was a change in the way of looking at the world. All right. At this point. And the Origin of Species does not talk about the evolution of man, but he did write a second book, The Descent of Man, which he hinted at it in Origin of Species. In Descent of Man, he went and said, okay, let's just have it out. Yes, these ideas could be used to suppose that there is a common primate ancestor from which other primates have descended. And again, he's just looking at the commonalities in their anatomy. And he has a mechanism, remember, how could they get from one to the next? Because of natural selection. All right. Meanwhile, back at school, well, up until this time, universities were usually sponsored by churches. Okay. But this was because of this at this point in time, you start to get this split. All right. The academic side started to diverge from the theological side because they were starting to have some trouble reconciling the conclusions on the scientific side from what was known in the theological side or understood at the time. And so you're starting to get this division. And it was this idea of a parson naturalist, where you'd be a parson, a church guy, and go be a scientist on the side. Well, that that idea kind of broke down, okay, as time went on, as these two things, and even today you see that quite a bit. You know, there is the church side of a university and the academic side are often um, historically related, but they go their separate ways. It was no longer the main way of doing things. All right, so 1868. This is Darwin, 1868. He grows that famous beard during this time. I think he was away at one of his, he was away at one of his therapy sessions, for his illness or whatever. He grew a beard while he was away, and when he came back, he kind of liked the beard and kind of became a kind of a bit of a symbol for him. And he kind of had a little fun with that, I think. That's how they draw him, with the crazy beard and things like that. Okay. In Descent of Man, 1871, he goes ahead and goes ahead. Okay, well, let's talk about human evolution. All right, that's on the table, and the idea of sexual selection, where again, they're building on this idea now. This is beyond natural. This is saying where why do birds have crazy colors? Well, they have crazy colors because crazy colors demonstrates fitness, and the female associates crazy colors with fitness. Okay, and so the female is more likely to breed with the crazy color version because it took energy to make that those feathers that are those crazy colors that took away from being able to eat. And so he must have energy to spare. Therefore, he must be a good provider. And therefore, I shall mate with him. Okay, that's the idea of sexual selection, where animals will pick things, and they're picking up on signals. There are signals in the behaviors of the courtship that demonstrate the fitness. Okay, and that's the idea of sexual selection. Well, as we say, this really got got things moving. And we got this famous drawing of Darwin as a monkey, that men were descended from monkeys, Descent of Man, and that the popular press had a great time with that. And even today, that that idea of Darwin and the monkey thing is a pretty famous diagram. Well, Darwin was no slouch. He was not a one-hit wonder. He did two major works on this topic, but this whole list on the side are all the other things that he did. He published lots and lots of papers. Even when he was in school, he had credits in scientific papers, and he was never a professor. Remember, he was basically just a rich guy, but a man of means. But he used his time to be a scientist basically on his own dime. Okay, but he did make some money then from his books, because he made some money from his Beagle book, and he made some money from his Origin of Species book. So he made his own way eventually. But either way, even though he was never a professor of anything, he was a very accomplished scientist, as we can see here from his extensive writings. Well, in 1882, he died of a heart condition, is what they have. And they're not from his mystery disease, but apparently just from a heart condition. And he intended to be buried someplace else, someplace modest place, but he was well known enough at the time, and he had lots of friends, and they said, you know what? We're putting this man in Westminster Abbey. So he's buried in there next to Newton, okay, and a couple of other big important scientists. So he was that important when he died that people knew what his contributions were. They gave him a place in Westminster Abbey. So after Darwin, actually, we had kind of what's called the eclipse of Darwin. That is from the 1880s to the 1920s. Darwin's natural selection kind of lost popularity for a while. I'm not sure what they replaced it with. But I guess maybe sort of held back on some of those ideas, and there was some debate over whether it was really, because it was hard to see, right? I mean, you could posit this from what you see now, but to see it in action, you can't really see it in action, at least not in a macro sense. You're not going to see two birds become two different species very readily today. We can see them kind of heading that way, but you can't really see it happen. So, he had a mechanism, but he didn't really have, shall we say, the biology to back it up. That came with the rediscovery of Mendel. Remember, Mendel published in 1860. Darwin knew nothing of Mendel's work at all, even though he had published back then. People ignored the paper. Okay. I think I'm not sure if he's even published in English. I'm not sure. But at any rate, and then the idea of genetics uh, was developed in the early to mid 1900s. And that brought Darwin back into it, the idea of natural selection, because now, yeah, they had sort of an explanation mechanism, but now they had the details to back it up, and they had the chemical, the cell biology to back it up as well. And then genome sequencing today is basically on this idea, okay, that these heritable characteristics are reflected in the genome. And by going back and looking at the genome, you can see if the genes are the same, the gene patterns are the same, then these two things must be related. And how do they get to be related to each other? Well, the only way you're going to get your genes to look like the other guy's genes is if you inherited them from him, okay, via parent and offspring and that method. And so we end up with what we have today. This up in the upper left-hand corner was Darwin's sketch of his first, shall we say, tree of life, if you will. And it says up in the upper corner, it says, I think. Okay. And then he drew this thing. This is famous because it was kind of like, and this is fairly early. It's like 1839 or something like that. He sketched this fairly early. He sketched this in this journal fairly early with the word "I think" at the top. Okay, and that's where he started. And this is what we have today. This is what you get after you do genome sequencing. And now we have everything in this tree of life. And we have all these relationships mapped out. So that's what it looks like now. And of course, that is, you're representing literally probably, I don't know, millions upon millions of species, whatever many species there are on the earth. There's 2 million of species of beetles alone, for example. And there they are, all mapped out using this idea that Darwin came up with. It's kind of like the ultimate catalog. He had all these specimens. He needed some way of making sense of how they related to each other. And this idea of natural selection was a way of figuring it out, and that making the catalog make sense. And now this tree of life that I have in front of you, that is the catalog that is used today. So there you go. There's the Voyage of Darwin, kind of how he came from I don't know, shall we say a rich kid, and with with spare time on his hands to become one of the foundations of modern biology.